Okay, this first video is on algebraic expressions and combining like terms. So this is where we're going to be using a lot more things with x's and stuff involved in it, so it gets a little bit trickier. What I'm talking about. First of all, what is an algebraic expression? An algebraic expression is a mathematical sentence which involves letters. So for example, if I put x plus 2, that's an algebraic expression. 3y minus z or z, that's an algebraic expression. Okay, so there's no equal to sign. If it was x plus 2 equals 0, that wouldn't be an expression, that would be an equation. Okay, so it's just an expression, okay, it's just a sentence. So if I have 5 or 4r minus 1, there's another one. What about 7b minus 2a plus 1? So these are examples of algebraic expressions. Now the next bit, what are terms? The terms are the pieces that make up the expression. So for example, if I look at this one here that I've just written, 7b minus 2a plus 1. Well, what are the terms in that? Well, the first term is the 7b. It's not just the 7, it's the 7b. It's that one piece. The second term would be the minus 2a, and the third term would be the plus 1. So there's 3 terms in that expression, and there they are. If you look at the first one, up here, which I highlight, it's very simple. The first term is the x, and the second term is the plus 2. If there's a sign in front of the letter, or the front of the number, that goes with it as part of the term. And finally, the last piece, what are coefficients? Again, look at 7b minus 2a plus 1. It's the numeric part of the term, the number part of each term. So look at the first term is 7b. What's the number part? 7. So we would say that 7 is the b coefficient, because it's the coefficient of the part with b in it. Look at the minus 2a. The numeric part there is minus 2. So minus 2 is the a coefficient. And the third part, plus 1. Plus 1 doesn't have a letter, so we say it's the constant coefficient, or the numeric coefficient. Okay, so that's it. It's really simple, just identifying the parts of an expression. So let's move on. So first up, here's an example. So we're going to simplify by combining like terms. So what that means, you can only add 2 pieces together, or you can add 2 or more pieces together, if they have the exact same variable part. Okay? So, if we look at the first one, well, we have one term which has x as its variable part, and another which has x. So they can be combined. So if you look at the first one, I have 7x. I take away 4x's, minus 4x. So if I have 7x and I take away 4 of them, how many do I have? I have 3x. And now look at the last term, this here, the plus 3. There's nothing to add that to, because there's no like term. Okay, there's no term. This 3 is just a number. We can only add that to other terms which are just numbers, and there's no other term which is just a number. So that just stays as it is. Okay, so when you simplify that, that's what you get, 3x plus 3. What about this one here? This is a bit longer, a bit bigger. So let's look at each part. So look at the first term. So the first term is 2. So I'm going to write this out a little bit bigger, the whole thing. So we have 2 minus 5x plus 6y minus 2y plus 4x minus 8 plus 3z, or 3z, whatever you want to call it. Okay, so look at the first term is 2. So 2 is a numeric term. Okay, so I'm going to highlight the 2. Now, look at other numeric terms. We have 2, okay, minus 5, no, plus 6y, no. Keep looking along. Where's the next numeric term? It's minus 8. So we can combine those. 2 minus 8 gives us minus 6. Now, so they're gone. We've combined them. Now look at the minus 5x. So what's the variable part of that? It's x. So look for another one, which is the variable part, which is just x. So we have minus 5x, we have plus 4x. Okay, so if you have minus 4x's and you add 4 on, well, who wins? The minuses win, so that means you have minus 1x, or just minus x we can call it. Now, the next term is 6y. Look for other y's to combine that with. We have 6y minus 2y. So how many y's is that in total? Plus 4y. And then, all the terms have been removed. The only one that's left is the 3z, and there's nothing to combine that with, so it just stays as it is. Okay? Simple. What about this one? So, what we're going to do here, again, the variable parts are a little bit more complicated here. So if you look, we've 8xy. The variable part is xy. We want other xy's to combine that with. We cannot combine it with x squared y's. We cannot compare it with xy squareds. We can only combine it with xy's. So how many xy expressions have we got? Okay. This one has the xy. So we have 8xy minus 3xy. So that gives you 5xy. Okay, the variable part has to be exactly the same. So now we have minus 4xy squared is the second term. Xy squared. Are we any other xy squareds? No. We have x squared y's, but we don't have xy squareds. So that just stays as it is because we have nothing to combine it to. Next is x's. We have a 3x. Have we anything else? Yes, we have minus 4x. So if I have 3x's and then I take away 4x's, I end up with minus 1x. This is just integers, or minus x you can write as well. Next term, minus 7y. Anything else with just a y variable? No, so that stays as it is. Then we have x squared y. 6x squared y. And we have another x squared y. So we have 6x squared y plus x squared y. 7x squared y. Okay? That's it. Because the 6x squared y and the 7x squared y were combined. And now we've combined all the parts that have the same variable. All the terms with the same variable part have been combined. Now this can't get any simpler. I can't combine xy's and xy squareds. It's impossible. It's like trying to combine apples and oranges. You just can't do it. They're different. You can only combine them when the variable parts are the same. And that's it. So you'll see now on Moodle there's a video that you can look at. There's a worksheet you can work on, So you can work on the video now, or use the video to help you. And then we're going to move on to laws of exponents. So have a look at that worksheet. Use the video for help, and I'm going to call some groups up to work with me.